Hello everyone, I am a researcher at the Institute of Mathematics and Information Technologies at Petrozavodsk State University. Today I am going to talk about Smart Spaces middleware, a requirement-oriented overview. So let's consider the deployment problem of smart spaces in respect to the opportunities of emerging Internet of Things, web and semantic web technologies. This slide presents the steps of evolution from Internet of Things to semantic web of things. The Internet of Things enables the integration of a wide range of technologies and devices, from legacy technologies of home automation and emerging technologies for smart cities to any class of sensor, actuator, tag, or thing. The next step in the Internet of Things had been to connect things to the web, thereby conceiving the so-called Web of Things. These interactions are enabled through the definition of application programming interfaces over HTTP protocol based on web services following the RESTful architecture. Finally, Semantic Web of Things ensures the extension to the Internet of Things, allowing integration of both the physical and digital resources with the semantic web technologies. Smart Space supports a shared view on available resources in the Internet of Things environment and creates semantics for the use of these resources in cooperative construction of services. A Smart Space applies technologies from Internet of Things, Web of Things, and Semantic Web of Things to develop service-oriented application for ubiquitous computing environments, where the physical, digital, and social resources are semantically fused. Service construction is implemented by software agents running on various devices in the environment. The focus is on the resources related to a special restricted area, locally produced data, computational power of surrounding devices, expertise of participating users, etc. Semantics of such resources are integrated in a knowledge base, which is collectively created, maintained, and used by agents through a smart space middleware. Smart space middleware can be considered from the semantic-oriented viewpoint, reflecting the observable growth of using the semantic methods in Internet and Web of Things. Now we will look at a couple of research questions that need to be addressed. The first question is what requirements for smart space semantic-oriented middleware should be met to create an emerging generation of semantic web of things applications and systems? The second question is based on the requirements how to design a software infrastructure of a semantic-oriented middleware for smart space deployment in Internet of Things environments. Both the ground number of smart space application and the related concepts, specification standards impose requirements on a smart space middleware. The requirements systemize the properties that a particular smart space middleware can have. Such a semantic-oriented middleware should provide data integration and easy knowledge exchange and intelligent reasoning in smart space. Furthermore, it should resolve the problems of interoperability and integration with heterogeneous resources of ubiquitous interconnected objects and systems. Requirements for a smart space middleware can be categorized into three groups. The first of these is the functional requirements. They cover the functions provided by a middleware. In this slide, you can see the key functional requirements of a smart space middleware. Most of them are related to semantic web standards and solutions, such as machine-readable logic, inference, knowledge discovery, and data federation. However, such expressive logics and solutions have exponential time complexity that is of poor scalability and low performance when size parameters of data are growing. Therefore, the big data management analytics becomes even more important, providing the ability to effectively filter, aggregate, and collect data in or close to real-time mode. The second group of requirements is non-functional requirements. They describe constraints on the smart space middleware as a whole system or for a particular function. In this slide, you can see such key non-functional requirements as extensibility, connectivity and accessibility, dependability, semantic interoperability, security, portability and adaptability, ease of deployment, and engaging development community. For instance, in order to enable the interoperability requirement, the smart space middleware should support simultaneous operation of heterogeneous application when information is exchanged between applications and their services. The semantic interoperability means transparent and easy information exchange even if the set of participants is dynamically changed. The last group is application development requirements. On the one hand, there are a growing number of smart spaces applications impose requirements on simplifying the application development and software maintenance. On the other hand, the semantic web technologies impose unified standards for application development. Semantic web introduced the concept of semantic web services, which can be used in smart spaces. A smart space application also aims at constructing services with uniquely described semantics, accessible through the internet, and suitable for automated discovery, composition, and proactive initiation. Moreover, Smart Spaces middleware should provide application development approaches with heavy developer involvement and extensive use of tools of computer-aided design and computer-aided programming that support application prototyping. This slide presents an overview of particular existing middleware solutions that can be used for the case of smart spaces. For each considered solution, the overview focuses on the achieved level of requirement satisfaction. In general, service-oriented, agent-based, data-based, and graph-oriented design approaches address more smart space middleware requirements than others. Middleware based on these design approaches are LinkSmart, Sophia 2, SEPA, and Neo4j. It is worth noting that some requirements and related research issues remain relatively unexplored, such as semantic services and computer-aided design and programming. These requirements, with the ever-increasing number of smart space applications, are becoming more and more relevant compared to other requirements. The presented overview of the middleware solution led to our proposal of the infrastructure multi-layer model for smart spaces. This model is the initial step in the design of such infrastructure and hence simplifies the development of the middleware and service-oriented multi-agent application systems. The four infrastructure layers are defined: middleware base, middleware infrastructure, application systems infrastructure, and physical and information resources. The middleware base layer contains the main modules of middleware: shared knowledge base, storage for data or metadata about agents, agent management, agent discovery mechanisms, and modules that implement protocols. This layer allows agents to register in the smart space and find other agents to communicate with them using protocols supported by the platform. The middleware infrastructure layer contains agents and services to extend functions of middleware base layer and provides a functionality for a specific domain of application systems. The application systems infrastructure layer contains agents and services that enable the interaction with physical and digital resources implementing smart space applications. So, in conclusion, this work is systemized requirements applicable to development of smart spaces middleware for Internet of Things environments. The existing solutions are compared and basic approaches are identified to this type of middleware development. In general, service-oriented, agent-based, data-based, and graph-oriented design approaches address more smart space middleware requirements than others. The presented overview led to our proposal of the infrastructure multi-layer model for smart spaces. Some requirements and related research issues remain relatively unexplored, such as semantic services and computer-aided design and programming. The way of satisfying these requirements will be presented in a future work. Thank you for your attention.